Great. Hi, everyone. Thanks for having us here and coming in to listen to us. We're going to talk today a little bit about how to deal with the whole migration from north-south traditional traffic to east-west traffic and some of the problems that arise in the enterprise network environments due to that. I'm David Levin with MidoNet. I run sales for the east of the U.S. here. And
I'm Richard Wong. I'm the SE for East in MidoNet.
Great. So I'm going to keep the commercial part of this really, really short. So MidoNet is essentially a Neutron plugin. We've been around since 2010. We are one of the lead contributors to the Courier project, which is essentially the idea of Docker containers through Neutron. And what makes us pretty unique is we provide a fully distributed model where we have a network state database as opposed to a controller. And all of our L2 to L4 services are fully distributed. And then what I'm going to do now is set up kind of what the problem is here that we're addressing. Ooh, my formatting's messed up on this laptop. Anyways, so one of the challenges that we see today is the default networking in OpenStack essentially has some vulnerabilities in its design. It is pretty inflexible as well as it's complex. And when you have any number of VMs or containers that go into it, it becomes much harder to manage with IP tables. I'm going to let Richard take you through the technical aspects of this.
Thank you. So the default networking in OpenStack is not quite enterprise ready. We see that with OVS. And I just want to run through a sample network communication session of how a session is established. So for example, we have a session that's trying to go out from VM1 out to VM2. In order to do that, it has to traverse, it goes out to the Linux kernel, goes back to the OVS agent locally, runs through IP tables, okay, is allowed to go out to the kernel, goes out through the network, hits the network node where the Neutron server is. In this example, we compress the Neutron server to the network node, hits the kernel, then it goes to the layer 3 agent, determining from the IP tables this is permit or not, hits the kernel again, and then up to the OVS agent, back to the kernel, back out to the compute node 1, installs a flow from the OVS agent saying, hey, I'm allowed to go to compute node 2, goes to compute node 2, talks to OVS agent again, sets up the flow on the kernel. Then from VM1, it starts traversing the traffic through the compute node 1's kernel again and back to compute node 2's kernel and finally to the VM on compute node 2. When you add microservice containers into the mix, the complexity on the network expands exponentially because you have a lot more components and touch points and endpoints in the entire mix. So when containers and hosts start talking to each other, you have a lot more cross communication between all these machines, and that further complicates the communication and the management between all of your hosts and all of the containers. And okay, so the scaling on the network becomes much more of a challenge because your complexity is just growing out of control. And obviously, with Docker being so popular nowadays, we have NAT Bridge to define all the networking for IP addressing and ports. So that provides a simple answer and solution to the problem of being able to map a lot more Docker instances per host. But it comes with drawbacks. You have no way to simply manage, for example, communicating from Docker instance running on host 1 to Docker instance running on host 2. So cross-host management becomes much more of a challenge. And we also have no advanced networking, meaning you don't have any centralized way to manage all of the security between all these Docker instances. So a further challenge is that OVS in OpenStack by default sets up all these IP tables, and you have all these islands of IP tables, and you can't scale them because you have all these separate little hosts, hundreds or thousands of them out there, and how do you manage all the IP tables? And when your enterprise starts growing, you start adding more and more rules to your IP tables, and it becomes a bit of a challenge when you start trying to read through all the IP tables and parsing it, and it becomes even more of a nightmare where you need to make modifications, delete things, change things. There's occasions where the rule sets become so long that it starts timing out, and as sysadmins and engineers start experiencing these kind of issues, a lot of them shut them off because they're not actually network engineers. They start delving into the network engineering area, and it starts opening up a big can of worms in terms of security and managing the security on these servers. And so with virtualization, we've seen traditional traffic going from north-south switching a lot more to east-west, and virtualization has expanded the use of traffic from inside data centers to a lot more horizontal traffic. And containers have really pushed the traffic to a much more horizontal scale. However, in the traditional model of north-south traffic, you have perimeter security and firewalls, but when you switch to an east-west traffic model, we have a lot less checking of each of these endpoints within your data center. So how do you check all of the servers? How do you check all of the containers to make sure that the security is being followed? That becomes a big challenge. So the answer is OpenStack provides an answer to the whole model. In Neutron, there is a security group definition. So we can define all the security group models. We can push them out to virtual machines. We can push them out to compute nodes and containers. However, not with the OVS model because OVS doesn't extend that. So in order to do that, you have to have some other network model that can extend what Neutron defines. So for these centralized security groups, you can actually follow the methodology that Neutron explains and manage. If you, in theory, if you make a change to these security groups, you should be able to extend these out to all of your hosts, all of your containers, and make one change and it affects all of your hosts, all of your regions in one shot. That's the ideal scenario. So MidoCora provides a plugin that solves that type of problem. We just plug it in and we follow Neutron's rules. We don't change anything. We extend it out to all of the machines. You make one set of rule changes and it doesn't use IP tables. It just pushes everything out to make it centrally managed, more secure. You could flexibly make agile changes, and it's easy. It's it keeps things simple.
So, thank you. That was very informative.
So,
additionally, we also have a dashboard that makes it really easy for troubleshooting on getting insights. We call it MEM Insights. That's worth taking a look at to be able to make this easier and scaling and managing this stuff. But thank you for having us. We appreciate it.
Thank you.